Hello, everyone, and welcome to Auth, Part 1. This is the first part of a three-part series where we will explore the techniques and philosophy behind authorization and authentication, mostly authentication. All right, so let's take a look at what we're doing the next couple days. So this comes in three parts, as I mentioned. What we're going to do today is learn how to create users in a Rails backend. Tomorrow, we're going to learn how to authenticate users, meaning, all right, you made a user. How do I know that you're that user and not someone else? And then on Wednesday, we're going to say, all right, well, now that I know who you are, how do I know that you're allowed to do whatever you're trying to do in the app? So for this first one today, by the end of this lesson, I hope that each and every one of you will be able to create new users in Rails and explain how hashing works. So if it's been a hot minute since you've done Rails, here's this handy reminder of how the model works. HTTP request comes into the router. It's going to match a method and an action to a method and a path to an action on a controller. So find that controller, find the right action. Inside that action, we're going to do something with the model. Model does our database interaction, comes back to the action. Action fires off a response. So in the 80-20 of Rails stuff, this is the 80% of Rails is all stuff that's kind of this shape. So creating a new user, not that crazy. Most of it is exactly like every other resource you've ever made in Rails. You're going to create a route to create a user, make a controller create a user. The logic inside that controller looks just like all the stuff that you've done before. The two things that are going to be different are this little Bcrypt piece right here, and then how we store a user's password. So we're going to do this three different ways. First way, you're going to watch me do this. Then we're going to collectively do it together. Then you're going to do it on your own. Questions before we get started? All right. So watch me. Don't try to follow along. Look, big picture, macro, that kind of stuff. So I'm going to fire up a new Rails project. So I'll call this Rails new --API auth December 1. This is going to scaffold out a Rails app for me. And then the first thing that I need to do is install Bcrypt. Bcrypt is a Rails gem, and it's actually already in your gem file. You just need to uncomment it out. So if I go into this folder, and fire up my gem file, right down here, that line right there. All we got to do is take out the little hash in front of it. Pew, pew. Now to actually install it, bundle install. That's going to read the change to our gem file and install the new gem. Step 0, complete. Okay, step 1, create a route to create a user. So we're creating a resource. So who can tell me? Actually, I'm going to call on somebody. Think to yourself for a sec. If I'm going to create a route to create a user, what would that route look like? Think to yourself. Augie, give me an idea.
Oh man, I don't know. I was writing, to be honest.
Okay, so if I'm creating a resource in Rails, what does that route usually look like? Think about method, path.
Well, you'd have your controller, and then you'd have to create methods, your index, create.
But like just the URL, what HTTP method, what HTTP path?
Oh, gotcha.
Which method creates things?
Post.
Yeah, there we go. So it's going to be a post request, and we've got like a couple different ideas for what the path should look like. Some of them have the ID, some of them don't have the ID. If I'm trying to create a user, what does the path look like? The post request to slash what? Users. So a post request to users should be the thing that handles creating a user. Thank you, Augie.
Sorry, I had an alarm going off in the background.
You're all good. So a post request to users. And we want to send that to, I'm going to call on somebody else for what the controller in action should be. Think to yourself. I'm going to send it to Alan. Give me an idea.
So I've been watching enough these videos. I mean, I would say authentication and login.
Cool. So those are going to be for like creating, for like logging someone in. We're just making a new user. This isn't even different than anything we've done in like mod 2.
Right. So that would be, yeah. What Jordan typed. User pound create.
Users create. Like that. So controllers are plural, models are singular, always. So since we're going to the users controller, plural, we want the create action on it. All right, that's step 1. Step 2, we want a controller that creates the user. So we want this user's controller, and we need to put a create action on it. So I'm going to Rails G controller users. I'm going to make a create action. What goes in the create action? Not so very different than anything that we do in Rails. Well, we can put anything we want on this, but for now, we're just going to worry about username and password. Wrap that. Cool. Nothing Auth specific yet. This is the same. If we were creating a user in mod 2, this is the same thing we would do. That's step 2. Step 3, create a user model with a secure password. So since this is a model, is it plural or singular? Think to yourself. Javarie, are models singular or plural?
Oh, sorry, my mic was muted. Models are singular.
Yeah. Very nice. Good job, Javarie. We're going to make user. All right. And it needs to have a secure password. Okay, so this is the only like really Auth specific thing that we do in this entire part of it. So we're going to go over to this model file for it. I'm going to do has underscore secure underscore password. That's it. That's all there is to it. This works the same way as like has many belongs to. It's a macro. So this is going to put everything that we need to have a user with a password. Going to take care of that for us. It's pretty cool. And then we need to take a look at the migration that it made for us. And we need to tell it that we want a username. We need to tell it that we want a password underscore digest. That's the easiest thing to forget in this entire process. In the controller, it was called password. In the actual database table, it's called password underscore digest. So if we look back at this thing right here, post request to users comes in. Well, post and users goes to create users. All right, so we find the users controller. We find the create action on it. Pull up that user model. Like, hey, make a user with this username and password. That has secure password thing in the model goes, cool, I'm going to translate password to password digest. I'm going to put that in the database. I'm going to pull that out of the database. I'm going to send it back as password digest.
Is that just like some sort of automated, the word like translator, basically to like hide a password from what it actually is into something else?
You're beautiful. That's exactly what it is.
Okay.
Cool. And that's it. So let's see it in action. I actually run my migration. Rails db migrate. Rails S. All right, so I'm over on 3000. I'm going to pull up Postman. If you somehow manage to make it this far without having Postman installed, it's a fine time to start. All right, and then we're going to post to localhost 3000 users. We're going to make sure that we've got a raw JSON request going out. We're going to send a username and a password. And let's see what fires back. Pew! That's how you create a user in Rails. Ask me some questions about it.
Well, the elephant in the room would be password digest.
Mm-hmm.
That's a lot more than what you put in.
It is. So we're going to talk about that a little bit more. That's the second objective, explaining how hashing works. So we'll get to that today. Other than that, questions about this process?
Why is Ruby on Rails so goddamn easy? Like it's just too simplified for everything.
This is pretty easy. These steps are actually exactly the same in just about any backend auth process that's doing this kind of thing we call token-based auth. And it pretty much all works like this. The equivalent thing in Express is a lot more code, but it ends up doing the exact same thing.
I'm just digesting this. That's weird that I use that word, but basically the only thing I'm taking away from this is digest is like everything else is the same as what we were doing before. And now we're just adding that digest.
Correct. That's it.
Okay.
So the reason that we want to do that is my top secret password here, I don't want it to go into the database. I don't want to store it. I don't want to be responsible for it. I don't want somebody to compromise my database and then have all of my users' passwords. No way, no how.
Yeah, it's funny. For my mod 1 project, we totally like made a fake log in. I mean, it actually worked. Like it required an accurate password and everything, but I was like, there's no way that this is the right way to go about actually this, because we were just storing like username dot password as a
You are correct. So we'll talk more about why in a sec. Any other questions about this process? All right, cool. Let's go through it together again. So I am going to wipe. All right, blank slate here. Starting all over again. Jack, give me one step towards getting this done. You're muted if you're talking.
Sorry. Okay, so the first thing you need to do is create a route to create the user. Or well, I guess, have you created the Rails app yet?
No, I haven't.
Okay, yeah, so you have to create the Rails app.
Yes. So the Rails new API auth December 2. All right, cool. Augie, give me another step.
You can uncomment your gem file for Bcrypt.
Pew, pew. Good call. Oops.
And then bundle install.
Excellent. That's our step 0. So this was auth. I'm going to open up that gem file. Go down here. Just make sure I got that. All right, so that's uncommented out like so. And then I bundle install. Very nice. Jordan, give me the next step.
we're going to create the route to create a user.
Yes, we are. And what goes in it?
We're going to post users.
Yep.
To users hash create.
You're beautiful. Cool. Alan, give me the next step. Oh, you're muted.
Go to your controllers. You need to make the user controller.
Yes, I do.
Yeah.
Is it the user controller?
Users.
There we go.
Yeah. Polish plural. Model singular.
There we go. That's what I want to hear. Rails G controller users. Very nice. Gerald, give me the next step.
Want to write your create action in that controller?
Beautiful. What goes in here?
So at user equals user.create, parenthesis, braces. We want our username or a password.
How do I get the username?
Params.
Good.
Brackets. Yeah, there you go.
Okay. Wait, is this one password digest?
No.
Correct. Very nice.
Do we need that last comma on your 5? Well, now on.
No, but I like them, and here's why. The order doesn't matter in a hash or a JavaScript object for that matter. And when you put trailing commas on, you can flip the order around willy-nilly without having to, because like if I did that this way, I'm gonna flip the order on these. Oh, now I don't have valid syntax.
Right.
So like everywhere that trailing commas are supported, I generally use them. The one notable place where you cannot do trailing commas is on JSON. So like over here, you cannot put a trailing comma there, it'll break. See, it's mad at me.
Cool, thank you.
Excellent.
Real quick, Carl, so the trailing commas on that will never mess things up as you're pushing to or from JSON? Okay.
Correct. So JSON, actually, let's talk a brief detour. Let's talk about JSON real quick. What's JSON stand for? Anybody?
JavaScript object notation.
Thank you. Let's tear apart that acronym a little bit. It's not JSO, it's not JavaScript objects, it's JavaScript object notation. So things like hashes in Ruby, things like objects in JS, things like dictionaries in Python. These are all like the same idea. They're key value pairs. We can't send, like these are complicated things. We can't send them over a network. If I'm trying to send them between computers, there's no way to do that. Like they're part of the language. We can turn them into strings that have all the data that these have. We can and do. And the most popular format for that is JSON. So it gets used outside of JavaScript. It just uses very similar syntax to JavaScript objects. That's why it's JavaScript object notation. So we send it over a network through JSON, and then whoever is receiving it can turn that back into a hash or an object or a dictionary or whatever like that equivalent idea would be in the receiving language. It's a data transport markup, but it's not an object. It's a string. It's just some characters. But we can kind of like dehydrate it and rehydrate it to this style of data type. So since it's not actually an object, it follows slightly different rules than JavaScript objects do. For example, have to use double quotes. Can't do double, single or double. JavaScript doesn't care. JSON cares. You need the double quotes on the keys and the values. Cannot have trailing commas. Always needs to be an object at the top level. You can't do like an array at the top level or something like that. Always key value pairs. So it's a little bit more restrictive than JavaScript is, but familiar syntax. Any questions about JSON?
So it's always object at the top level, always double quotations, always key value pairs.
Yep.
And I think you said a fourth one.
Keys are always in double quotes.
Keys and values.
Yes.
Oh, and no trailing commas. That was the last one.
No trailing commas. Anybody know what was really popular before JSON?
It's not Ajax, is it? That's different.
Oh, you're really close though. It's one of the letters in Ajax.
Oh, XML?
Yes.
Oh,
XML was how this mostly got done before JSON. Exact same idea, except XML. XML is a superset of HTML. So HTML is a type of XML. So all the syntax of XML should be very familiar to you. You do things like user, first name. So like we can do HTML like this. You can also just store arbitrary data in this same kind of format. So this used to be how we moved data around networks. Any guesses why we stopped and switched to JSON?
It looked a lot more expensive.
Why?
Because that's a lot more characters to try and send across the internet.
Bingo. That's 100% of it. Every attribute, we put the name of the attribute twice in here because we got to say when it opens and when it closes. in JSON, it's just keys and values. So since we're trying to send this over networks, every character counts when you're doing network requests. As I've told you many times, and I'll tell you many times again, the most expensive part of every app is the network request. So it stands to reason that if that's the most expensive part, then that's our bottleneck. So we improve performance by making that faster. Not having quite so many characters to send makes that faster. Cool, that was our tangent. We have created this user. We have a route. We have a create action. Javarie, how do I finish off this action?
Sorry about that. We would need to render JSON and have that with the colon, and then inside of the curly brackets, user key. Sorry, no, not with the at. Yeah, and then at user. Yep.
Yeah, very nice. Good job. Cool. Kevin Johnson, what's next?
I'd say we have to create our model.
I think so. So I'm going to Rails G. Well, you tell
Singular.
me.
Model.
Singular.
Yep.
Very nice. Oop, I've got to be in the right folder too, if that helps. Rails G model user. All right, and there it is. Cool. Alex Gabriel, tell me what I'm doing next.
You run Postman after Rails S.
All right, so I got over here, if I Rails S, I've got Postman fired up. What do you want me to do, Alex?
Wait, did you do the password digest part yet?
No, I didn't.
Okay, but did you migrate yet? I'm sorry, I got kind of mixed up.
That's fine. So this is where we ended up. I've created a model, but I don't have anything in it.
Okay, so in the model, you want to make sure you do the has underscore secure underscore password.
Yeah. Get some. Kevin Glasgow, what's the last step?
I'm sorry. I'm trying to get my stuff to work right now. I can't even create a controller right now.
You're supposed to be following along. You're supposed to be with us. All right.
I am following. It just keeps freezing whenever I would send the controller command. It wouldn't do
Because
anything.
you're not supposed to be coding yet. You're gonna have plenty of time to do that in a sec. All right. No big deal though.
All
so
right.
we're right here. One last step we need to do. I have the model. There's one other part of a model that we need to do something with. How do I get the database ready for this?
You have to migrate?
Yeah. Well, I've got this migration file. What goes in it?
Username and password?
Yes.
For now, I guess, yeah.
So there's one other gotcha. This is the easiest thing to forget in this entire thing. Kevin Glasgow, what is it?
To put the secure password?
Ooh, so we did that in the model.
Oh.
Over here, what is it? Remember, we did like, it's almost like a translation between, it comes in here and it goes to there. We go to the model. It was password here, and the model turns it into something different going to and from the database.
I don't know the word of it, but I know it like turns it into like a piece of memory, pretty much.
Starts with the D. It happens when you're eating food.
Oh, digest.
Yeah. All right. So then I'm going to run that migration. And now if I head over to Postman, I have successfully created a user. All right, it's going to be your turn to do this next. Questions so far?
If you're doing Rails G resource to do it all at once, would it be password or password digest?
Everything would be exactly the same. The only thing that's different with resource is you don't have to create the controller and the user separately. But everything else is the same. So then you'd have like resource, users, and then you would want to narrow that down to whatever you've implemented. So like that. Other questions? Anything that would get in the way of you doing this right now? Cool. All right, as a practical matter, I think that I have like 5 different Zoom accounts. I think I logged in with the wrong one, so we might get kicked out of this. I don't think we will though. Fingers crossed. If we do, I'll just throw another link right in the thing where we were. But I want everybody to take a couple minutes and go through these steps. You're going to do it a lot over the next 3 days, so get fast at it. Go.
Kyle, can I see your Postman real quick?
Yep.
Okay, thank you.
So you'll know you did this right if you can post to /users, any username and password, and get something that looks kind of like this back. That means you did it right. All right, couple minutes, go through the steps, go.
Damn, who was it saying this morning she had to update Omazation, like restart her computer? I think I might need to do that right now.
Okay. All right, so give me a fist of 5, where fist is I have no idea what we're supposed to be doing. 5 is I got a hash password coming back. Cool, cool. Thank you, Javarier. Alan and Gerald, fist of 5 on whether or not you got a hash password coming back on your request. Thank you, Jordan. Thank you, Gerald. Thank you, Kevin. Alan, how far did you get? All right.
Not any. My computer borked.
Oh.
I'm in the middle of it, so I'm pretty sure I've got it, but I'll just take a couple minutes and I can verify.
Okay, cool. So, any new questions that came up while you were working on that?
I'm just so used to having the routes already kind of filled in for me from doing Rails G resource. I forget how to format the route.
Awesome. So let's talk about routes a little bit. We have a couple different syntaxes that work for this. So this one is method path controller action. So when we do resource, it's just a shorthand for all of these in a standard format. So like if we were doing Rails G resource for users, we would have get users. We would have one for the ID. We would have a put and a patch for that. And we would have a delete. So all of those is that. Now, what if I did your code review in mod 2, I probably beat you up for this at some point. This is equal to this. And if you didn't implement all 5 of those actions, don't run it wide open. So like if you only have create in there, specify that you only support create. So you have this only option for this that takes an array of all the actions that you support. The difference is that if I try to get something or show something or delete something with this, it's going to 404 and say, I don't know how to do that. If you try to do one of those things with this and you haven't actually implemented those actions, it'll just crash your server. Much better. Alex, questions about routes now?
No, that's good.
Anybody else? Questions about routes or anything else?
So I'm very used to seeing, so that the syntax that you're using, you're putting the users in quotations.
Yep.
And I'm used to seeing that part as a symbol.
I think it still works with symbols. Like if you do that, I think that also works. Rails is like pretty nice about symbols versus strings. I don't think you can do things like this. I mean, this would really just be for the routes. But yeah, it's all fine.
Okay.
Other questions about any of this? Okay, So this is one you want to get solid at. Because the very first thing I'm going to ask you to do at the beginning of this tomorrow is exactly what we just did. So this is one worth getting some reps in on. And that is creating new users in Rails, the foundation of all the stuff we're doing. So our second objective is explaining how hashing works. So this is where we're getting into a little bit of the theory. What is all this shit? I entered in Kyle and I got back all this weird stuff. What's worse, if I try to create another user, watch how the hash changes. Put in the exact same stuff, I got a totally different hash. If I keep creating them, I'm going to get different hashes every single time. What gives? So let me teach you about Kyle's shitty hashing algorithm. It works like this. It's just letter number substitution. So I enter in cab. That's my password. So I call that 312. And then I just add them all together. So 3 plus 1 is 4, 4 plus 2 is 6. So I'd say that the hash of cab is 6. So if I have 6 stored in my database and you steal my database, how would you get my password?
Let's reverse engineer that or deconstruct it.
How?
Well,
You don't know how you got 6.
Don't know how you got 6.
Basically brute force it.
How? What are some other ways I could get 6?
A 6 times, B 3 times, F.
The letter F. All of those are perfectly valid ways to generate that exact same hash. So you can't reverse it. That's part of the design of it. Now, if I try to log in and I give you my password, cab, can you make a statistical guess on whether or not it was the original thing that you entered? Yes. So this is Kyle's Garbo hashing algorithm. There are better ones. So what we're relying on is really super big numbers and statistics. So one of the qualities of a good hashing algorithm is that if you know what a hash is, it is statistically impossible for you to intentionally create something that has that same hash. It will always be possible for you to get to the same hash in multiple different ways. The likelihood of you being able to do that on purpose is effectively 0. That's hashing. So when we put in Kyle, it scrambles that up. Hashing isn't a math word, it's a breakfast word. It's talking about hash browns. If you grind some potatoes onto a griddle and you start mixing them up a little bit, and then you put some other potatoes on there, you mix them up a little bit, you put some other potatoes on there, you mix them up a little bit, you can't tell which piece came from which potato after a while. They're all mixed up. That's hashing. So the whole point is that this is what's stored in the database. They don't know what my password is. So how do they figure out whether or not I entered in the right password?
Well, wouldn't So if your hash, whenever you enter that password again, it runs through the same process and will match the hash?
Correct.
Does that mean that theoretically you could have a different password that would equal the same hash, but there's absolutely no way of knowing that?
Correct.
Got it.
Because the one that generates the same hash isn't going to be Kyler. It's going to be like a super long string with a bunch of random characters and symbols and whatever else.
Why when you created a new username with the same password, then did it come with the same hash? Is it because it's user 2?
No. Super good question. How come I got the same password, I ended up with a totally different hash? So these hashes are salted. Also not a math term, also a breakfast term. So the idea here is that take a look at this hash real carefully and watch which parts change and which parts stay the same. Which part stays the same?
The beginning.
The beginning part. So this first part is a description. This is using version 2A of the hashing algorithm. It's doing it at a cost of 12. You can do, you can attack a hash. If you don't hash it very many times, you could say, all right, well, I can generate a list of things that I think would generate this. Like if you had a computer that all it did was trying to come up with possibilities that might do that. If it's using Kyle's shitty hashing algorithm, that's not very difficult to do. And so like, there's always this like race every year against like, can we, as computers get faster, it's not as much of a performance hit because like this takes time. So like, if you don't want it to take 5 minutes for your login to complete, like you have to be pragmatic about how hashed it really is. But computer gets faster, cool. Well, then I can make it more secure. Also, a cracker's computer gets more fast also. So like this number goes up every like couple years. But it's the version 2A of the algorithm. It's calculated at a cost of 12. And then the first couple characters in this aren't actually part of your hash directly. They're just randomly generated. Whenever you make a new record, it just generates 5 or 6 random characters. So that's the first part of this. Then what it does is it takes those random characters, adds them to your password, and then hashes that. Let's draw that out. So my password is Kyle. When I make my new user, it generates a salt, which is AS $. So it's going to add that salt to the password that I entered. And then hash that, and that's what the rest of the characters are. So that way, when you compromise my, actually, who can tell me, why would you do this? Why would you make it more complicated?
Not like a predictable, repeatable thing, then you can't decode it to unlock someone's password, essentially.
Yeah, how would you do that? Like, you're right. That's exactly what somebody could do. Why? You compromise somebody's database, you get all 10,000 of their users, all the passwords are hashed. If they're not salted also, you can still probably crack a good number of them. Why?
You're like exponentially complicating it.
I am.
what are you asking the why about? Like, why would somebody do that? Or
No, so you get a database that has a bunch of hashed passwords in it. If they're not salted, you got a pretty good chance that a lot of your users are going to get compromised. Why? It's just a whole database full of things that look like this. Except everybody that has the password of Kyle would have the exact same hash. That's your hint.
because a lot of people aren't very smart with their passwords, and eventually, and you would notice a pattern of, oh, this one's a whole bunch of these ones. I wonder what password this could be.
Yes. So you do a distribution of which hashes show up the most often. And it turns out some of them are repeated. Turns out some of them are repeated a lot. You see this hash a ton. You see this hash a ton. This one shows up a lot. That one shows up a lot. That one shows up a lot. And then you see a bunch of one-offs. This is called a frequency attack. You're looking at the distribution of these things. And if you compared this to a list of commonly used passwords, ta-da, you cracked probably all of these. If you salt them also, there's no reason any two hashes in your database would be the same. But your user doesn't need to do anything differently. You haven't changed the user experience at all.
Are you saying the salt is this? Does it come back the same for each digest, or is it different for each one?
It's randomly generated.
Okay.
And it's actually stored with the hash. So the real hash part of this is like the last part of this. This is the version. That's the cost. This is the salt. And so when I'm trying to check to see whether or not what I entered matches, it's going to add these characters to Kyle and then hash those and see if the result equals this. It's pretty fucking clever.
Is there a way that you could like crack the salt? So for instance, like if you have, so everything has been you're adding the second hash using the salt, right? Mm-hmm. So would there be a way for somebody to like actually crack the salt so that then you could figure out what's going on there? Does that make sense?
Sort of. Like there's still a vulnerability here. It's called a rainbow attack. They're way, way, way more expensive to do. And they're not quite as effective. But like, it's not a secret which part of this is the salt. Like it's a published algorithm. So you go, all right, well, password is such a common password. What if I take these first 6 characters and add it to password and then try to hash that? But the thing is, there's an awful lot of different ways. And like the whole point of this is it's very difficult to intentionally generate a particular hash.
Right.
So there is technically a vulnerability there, but we're talking like supercomputers and stuff.
Sure. Okay.
And even still, it's only going to really work with very common passwords because you need to have like a published index of what all those hash possibilities are. It's only going to work with certain salts. And so you end up with something where like it would take you multiple like petabytes of hard drive just to store all the possibilities that would come out of that. And so it becomes very impractical very quickly.
Sure.
Other questions about hashing?
Where did the name of that term come from? Because just relating it in my mind to Ruby hashes, but obviously different than those.
Sure. So, man, that might be a conversation for another day.
Totally fine.
It's kind of interesting, but not hyper relevant to this.
Didn't you say it had to do with potatoes?
Yeah, like that's where the word comes from. Hashes get used in cryptography like this. It also gets used all over the place. So like all of your git commits are hashed. So if I go to something that's got some git commits in it, like this. Nope. Does Sparkwire have one? All right. So the first part of this, that's a hash. That's a hash. They take all of the files that you changed and the ways that in which you changed them and add them together and add them together and add them together and hash and hash and hash and hash and hash, and then generate a unique ID for all the changes that you made. And then if I want to go back to this one, I just have to put the first part of that hash in. So that's 6A64C. Git checkout 6A64C. And then it takes me to that commit. So we use them for IDs. Where else do hashes get used? They get used in data structures. So like the Ruby hash, it has to do with these things could be stored all over your computer. So how do you know how to store something that could have varying length, unknown length? Like where is it physically storing this data on the little like magnetic pieces in your hard drive? It could be spread all over the place. How do you find them? And like the answer is, well, you take the key and you hash it, and that like helps you figure that out. So they've got a ton of different uses in addition to making it so that you don't have to store plain text passwords. Other questions about hashes? Ultimately, it's some algorithm that takes an input and then generates an output. The output should be very difficult to predict. Should be something where like you can't intentionally create something that has the same result. It should just be astronomically impossible statistically. Like right off the bat, I think somebody commented that I put in something so small and I got something so big back. Yeah, it should also disguise like how big or small the original input was. The same thing with like the git commits. That's the entire hash for something that might have been a massive change. I might have changed thousands and thousands and thousands of files. You take all of those changes and you hash them and you hash them and hash them until you get down to this. So you shouldn't be able to tell whether it was one character or 500,000 lines based on the hash alone.
Is that the base 64 stuff going on?
No, base 64, we're talking about base 64 tomorrow.
That's a separate thing.
That's encoding. There's three related ideas, hashing, encryption, and encoding. They're three very different things, and we'll talk about all of them in this series. But spoiler alert, base 64 is pig Latin. It's just as easy to go one direction as it is the other. So we take a bunch of things in the input, mash them up, mix them up, boil them in a stew, get a difficult to predict output. If we put the same inputs in, we can generate that same output. Very difficult to intentionally create that output with anything else. I give them my password. I take some randomly generated characters, add them to this, hash that, check out the result. Hashing. All right, so I'm about to ask you to send me an explanation of what hashing is. If I ask you to do that right now, what questions will you wish you would have asked that I can illuminate?
So the algorithms, something inside of them changes the size of the total output. So I can see so your algorithm goes like down, it's reductive,
sure.
Right?
Well, imagine that like this input was like 9, 20, 15. So this could be 29, 34, 44. Okay, but the result has to be one character. So then we add those two characters together and get 8. So you just keep like mixing it down until it's the size, the target size.
Right. So I get how it would be reductive, but how do you turn Kyle into yada yada yada?
You start with a very large base. And so you go, all right, I have this completely randomly generated, it's called a genesis block. That's whatever the size of the thing is. That part is completely random.
So the salt is huge.
No, not necessarily. The thing that you start with is whatever your target size is. So like this is 20 characters or whatever. Your genesis block is a randomly generated 20 whatever the fuck thing. And then you start applying the algorithm to whatever gets passed in.
Yep.
This is the exact same way that cryptocurrency works, by the way. Like blockchains, you use blockchains in hashing. And so the first block in a blockchain is the genesis block. It's just random noise. And then your input tweaks that noise. If you'd like a long-ish form description of how like an actual hashing algorithm works, I wrote one up. Here. But yeah, like you start with a pattern, you transpose sections of these, you do a bunch of irreversible operations like XORing, and you flip things around. Like this is a description of like how an actual hashing algorithm would work. I'll fire that off. Other questions that would prevent you from describing hashing to me? Cool. Take like 2-3 minutes. I want everybody to Slack me in a DM. What's hashing? How's hashing work? Go. We'll do some work on it today, I promise. Looking forward to it. All right. Send me what you got. I will review everybody's answers and give you any feedback. And elsewise, hopefully this was useful. Hopefully you are now all able to create new users in Rails and explain how hashing works. First thing, when we do our auth lesson tomorrow is I'm going to ask you to create a user. So make sure you're solid on that. Get some extra reps in if you need. Elsewise, look forward to seeing you tomorrow. Cheers.
Thank you, Kyle.